So you're clearly a lot older than I am.
A little bit. This is skosh. A little bit.
I'm curious, when did structural engineering kind of really start to be prevalent in residential construction?
Well, I started in 96, and in 96, at the firm I was at, it was very prevalent in residential construction. We had engineering for foundations and post-stitching foundations from the beginning.
Okay. And engineering the foundation is required by every municipality we've ever built in, right?
True.
I mean, you got to do it. Why don't you think the framing engineering that we do on every one of our homes, why is that not like
Caught on.
prevalent?
Yeah. Well, I mean, we have a lot of builders that still live in the caveman days. And, you know, it's like, hey, I'm outside of the city. I'm outside in a non-annexed area. I don't have to follow and do anything. And that's not true. And so a lot of them are living in the past. And you know, we cherish more clients that understand that the code requires a lot more engineering outside of these areas than they think they do.
I mean, it's scary to me as a builder, right? Like I am, even as a mechanical engineer, I understand the complexities and the loading factors and the materials used, and it's a complex beast that often gets overlooked with, well, we'll just let the lumber yard use a span table, or
tell me
that's
about terrible. That's horrible. You don't want to do that at all. To your point, the industry will get generic plans. They will use just takeoffs. They'll use generic like span tables for their rafters and the floor systems. And that what you guys are getting with engineering, I mean, we are looking at where all the point loads are going. We're doing a full-on wind bracing plan. So we're getting all the lateral bracing, where those forces are going, hold down forces, overturning forces, point loads on your floor system. All of those things are absolutely important. And they make a huge difference in dead load deflections. Sometimes you can have differential dead load deflections where long spans, short spans, you know, we can tell you like, hey, you're going to feel a differential across the floor before you have it.
That's right. So one of the things I love about y'all's plans, they're well thought out from a practical perspective, right? Like you guys have clearly been doing this a while, maybe even framed in your past or something, because our framers constantly feed back to us that, man, these plans this is how I would do it. This is a practical plan. It's not over-engineered. It's not overly complex, right? But my favorite thing about working with you is you take the time to teach, right?
Correct.
So I have lost count of how many sessions we've had where you have taken the time to explain to me, hey, here's why I did it this way, and here's how the load travels through soil in a walkout basement. Or here's this point load diagram, and this 0.75 means that this beam is going to deflect by this much by design. So we did a floating beam. And
correct.
There's so much that goes into it that is missed when you don't have someone with y'all's experience, y'all's wisdom, y'all's practicality behind the plans.
Well, we appreciate that. That's for sure. We appreciate your attitude toward it. And of course, I totally agree with you that if you don't understand what passive pressure is for a retaining wall, you don't know what active pressure is for a retaining wall, if you don't understand how to grade things, if you don't understand dead load deflections, if you don't understand those things, you're going to have more trouble with your house.
You taught me what a wythe is.
What a wythe is. A brick wythe. Correct. Yes.
A horse and a wythe.
Wythe. Absolutely. So we'd like when we have clients, though, that care about the engineering, because, I mean, we're passionate about engineering, and we like it when our clients are passionate about it.
Yeah. What would you say to a client? Let's say if a client comes to you first and says, you know, hey, what's the next step? What's the first thing I should do? I have this lot and I have this idea for a home. What do I do next?
Find a builder. Find a builder. Find a good builder first. I mean, because we prefer to work for builders, and of course we like to work for builders that appreciate engineering. Absolutely, but find a builder first. Because then you are already beginning your project with reality. Because then from your builder, you can then have a builder select an architect, select an engineer. So I would have them find a good builder.
Okay. And what would you consider Younger Homes a good builder?
Oh, absolutely. Oh, yeah.
Shameless plug.
Oh, we love working with you guys. I mean, I know we're here doing a shameless plug, but I mean, engineering's engineering.
Yeah.
Period. It doesn't matter.
I forget what client number we are. I think we're like we're like 17 or 31 or something.
It's low down on the total.
It's low, and I've joked about getting it tattooed on my calf before because I'm so proud of being
It's a low number. So we do recommend, because we do have clients. Rarely does it happen, but they'll come in and they're starting first and they ask, hey, what kind of builders, should we look at?
Okay.
And then depending on the kind of product, there's no doubt that we are going to direct them to you guys.
What would you say if there's a builder checking this out, what would you say makes a good builder when you're partnering with someone like that on the engineering side?
One that's willing to communicate with us, one that's willing to look at different options. I mean, sometimes you have super long spans and we need steel. And then if we need steel and that's not in the budget, that's not in the plan, the architect kind of overcooked something and now we need steel, we can come up with different solutions. We can brace it different. We can do something different. So, I mean, communications is ideal to make sure the product that the homeowners are wanting comes in on time and on budget.
Mm-hmm.
And so if we can communicate with the builder and we can make changes, or we can communicate with somebody that has an engineering background that knows what we're talking about and cares, then we can solve problems really fast, make the plans efficient, and move forward.
Love it. That's awesome.
Mm-hmm.
I do want to circle back to something you mentioned. You mentioned, in talking with all the different loads on a house, you mentioned gravity and lateral loads.
Right.
It's something that, us, when Dad was building in Houston, it's something that we've always been mindful of is, using hurricane ties, H25 clips, and designing with that lateral wind force in mind.
Mm-hmm.
Out here, I think we do a 115
Correct.
mile an hour wind load.
115 exposure B.
Talk to me about that. Why do you do that, and why is that important?
Well, you absolutely need to do that. I mean, the wind forces will push on your walls, and if you don't have the wall grid line laid out, how you're going to transfer the force through the diaphragm to each wall, and then you have the sheathing on the wall designed properly, the nailing for the sheathing, the nailing for the bottom plate, the hold down for the bottom plate, then I don't know what you have. You have a pile of sticks, but and you have, an 1880s shack built by Uncle Jeb is one way to look at it, where you're just guessing, or we know where the force is going, why it's going there, and how to resist it.
Yeah, you may not know this, but we did a cost-benefit analysis on one of our homes that you guys obviously engineered, and we looked at a home that did not have this 115 mile an hour wind load rating, and of course our home that did have it. And the amount of money that it took to get that extra rating was about $1,100.
Yeah.
On a 3,000 square foot custom house.
Yes, makes sense.
And it's because you guys are looking at it from a practical perspective and saying this one wall is the only wall that needs this extra cross brace.
Correct.
That extra cross
Correct.
brace is a 1x4 lead-in bracing.
Yep.
Or
sheetrock.
Yeah. A GB wall or so,
Exactly.
So
Nailed 7 and 7.
there you go.
Yeah.
It's mind-boggling that this is not standard.
And it's kind of rocket science, but it should be. It's standard. I mean, for us, it's standard. Like getting the loads and doing all that stuff is normal for what we do, but it's shocking that people don't get it.
That's right. It's spending
I don't know what they're thinking.
It's spending the time and money on the front end, on the design side, right? So that you can have a better product that doesn't necessarily cost that much more. You get a much better value though.
But it's also being mindful, like I know what I want and to do it legally to get to the answer properly. So I'm not just guessing. Mm-hmm. It's not a guess. It shouldn't be a guess. Not at this level. It should be a guess.
Yeah.
We know where all the forces are going. We know why they're going there.
Yep.
Everything. Axial and lateral.
Yep.
No guessing.
And then I'd say the other thing that I love about Copeland Engineering is just, it's not just, we talk about all these awesome things and words with big syllables and all this cool stuff, but it doesn't just stop with the drawing, right? Like that drawing is important and it will get passed around to hundreds of trade partners, right? And that's their source of truth. But you guys come out and do a physical inspection at the foundation stage and we have you guys come out and inspect the frame at frame stage as well.
Well, and we'll even like on a house like this, I mean, this is going to have a lot of inspections. You've got really deep beams, tall beams. You have penetration requirements into the ground we want to come see. We'll want to see the steel in the walls. So it's not just one inspection. We'll come out many times on something like this.
It's truly a closed loop process.
Yeah,
right?
we have a full inspection department, trucks, team, communication, satellites.
Gary's awesome. Y'all have some pretty cool trucks.
We do.
Cars.
We do.
Black on black.
We do. We got some nice stuff, but those guys, we're trying to keep our inspectors for life, because I mean, it takes a very long time to train some of these staff at this kind of stuff that we do.
Yeah.
It's not a quick cycle time.
Yeah.
And so we provide them good equipment so they can be lifetime people that provide a much better quality product when they come out. They're not guessing. They're not young.
That's right.
They know what they're doing. They know what to inspect. And then they're not failing you on things that aren't needed.
Yeah.
And we're getting things that aren't.
Well, that's what I was going to say too, is people like Gary.
Wasteful. Yeah.
Gary is a fantastic inspector. And inspectors, in my mind as a builder, have a negative connotation, right? They're known as
they're the nanny, the caring, right? They're they're the inspector, man. No one wants to see the inspector come out like, here we go.
The inspectors that really rub us the wrong way are the ones that are just the problem identifiers. It's like, well, that's great. It's a problem identifier, but A, is it really a problem? And B, okay, that's great, but what's the solution? Help me work through a solution.
Right.
Gary and your entire inspection group does a fantastic job of not just being an inspector that identifies problems, right? They're on site, they know the practicality behind it, they know the drawings, and are able to propose solutions as well, or mitigate the risk altogether and say, this isn't really an issue.
Right, you don't want to be nitpicky and grab someone's duct tape issue over a post-tension tendon whilst missing 24 inches of embedment on a grade beam that's 20 feet tall.
Yeah.
Right. So we don't want to come out and nitpick duct tape when we need to be inspecting the important things.
Yeah.
Yeah.
I love the extra set of expert eyes, that you guys bring to the table. Yeah. And again, as Younger Homes is over the top about what you guys do, and love being a partner of Copeland Engineering.
Well, we appreciate the relationship as well, and we love partnering with builders that care about the building industry, care about engineering, and care about putting together a good product.
Thanks, man.
Thank you.